An arc fault circuit interrupter, or AFCI, is designed to protect against fires caused by arcing faults. A ground fault circuit interrupter, or GFCI, is designed to protect against electrical shock caused by ground faults. While both devices enhance electrical safety, combining them on the same circuit can present challenges. The core reason for potential incompatibility lies in how each device detects faults. An AFCI breaker detects arcing, which is a dangerous condition where electricity jumps between conductors due to damaged insulation or loose connections. These arcs can generate significant heat and ignite nearby materials, leading to fires. AFCIs monitor the current flow in the circuit for unusual patterns indicative of arcing. A GFCI breaker, on the other hand, detects ground faults. A ground fault occurs when electricity flows through an unintended path to ground, such as through a person touching a live wire. GFCIs measure the current flowing to and from the circuit. If there is a difference of even a few milliamps, it indicates that current is leaking to ground, and the GFCI trips to cut off the power. When an AFCI-protected circuit has GFCI protection installed downstream, nuisance tripping can occur. Nuisance tripping refers to the unwanted tripping of either the AFCI or GFCI breaker, even when there is no actual fault present. This happens because the normal operation of some electronic devices can create current leakage that a GFCI might interpret as a ground fault. Similarly, the switching power supplies commonly found in modern electronics can generate high-frequency noise that might trigger an AFCI. The National Electrical Code, or NEC, provides guidance on the application of AFCIs and GFCIs. The NEC specifies where these devices are required to enhance safety. It is important to understand these requirements to ensure code compliance and effective protection. The NEC mandates AFCI protection in many residential circuits, particularly those serving bedrooms, living rooms, and other areas where arcing faults are more likely to occur. GFCI protection is required in locations where there is a high risk of electrical shock, such as bathrooms, kitchens, outdoor outlets, and construction sites. While the NEC doesn't explicitly prohibit combining AFCI and GFCI protection on the same circuit, it's crucial to consider the potential for nuisance tripping. If nuisance tripping occurs, it can be tempting to bypass the protection, which defeats the purpose of having the safety devices in the first place. One approach to mitigate nuisance tripping is to use AFCI and GFCI devices that are specifically designed to work together. Some manufacturers offer dual-function breakers that combine both AFCI and GFCI protection in a single device. These dual-function breakers are engineered to minimize nuisance tripping while providing comprehensive protection against both arcing and ground faults. Another approach is to carefully select the types of devices connected to the circuit. Avoiding devices known to cause current leakage or high-frequency noise can reduce the likelihood of nuisance tripping. Additionally, ensuring that all wiring connections are tight and properly insulated can help prevent both arcing and ground faults. It's also important to consider the order in which the AFCI and GFCI devices are installed. In general, it's recommended to install the AFCI breaker upstream of the GFCI receptacle or breaker. This arrangement allows the AFCI to detect arcing faults throughout the entire circuit, while the GFCI provides localized protection against ground faults. If the GFCI is installed upstream of the AFCI, it may trip before the AFCI has a chance to detect an arcing fault. Troubleshooting nuisance tripping can be challenging. If you experience frequent tripping of either the AFCI or GFCI breaker, it's important to investigate the cause. Start by disconnecting any recently added devices to see if that resolves the issue. If the tripping persists, you may need to use a multimeter or other diagnostic tools to measure current leakage and identify potential sources of interference. It is crucial to consult with a qualified electrician to diagnose and resolve any electrical problems. Attempting to troubleshoot electrical issues without proper training and experience can be dangerous. An electrician can assess the circuit, identify the cause of the nuisance tripping, and recommend appropriate solutions. These solutions might include replacing devices, rewiring connections, or installing a dual-function breaker. Understanding the principles behind AFCI and GFCI protection is essential for ensuring electrical safety. By carefully considering the potential for incompatibility and taking appropriate measures to mitigate nuisance tripping, you can create a safe and reliable electrical system. Remember to always follow the NEC and consult with a qualified electrician when working with electrical circuits. This ensures that all work is performed safely and in compliance with applicable codes and standards. Electrical safety is paramount, and proper installation and maintenance of AFCI and GFCI devices are critical for protecting against electrical hazards.